Okay, on the other side of page 190, this is page 191. Find the equation of the line t other than q, which contains the point 1 minus 2, which is also a distance 2 from p. So we have to find the equation of the line. And the some line we don't know the equation of. We know that it's a distance 2 from the point p, p being 3 minus 3. So we're going to use the perpendicular distance formula, which would be d is equal to the modulus of ax1 plus by1 plus c all over root of a squared plus b squared. We're going to let this line t be some general line ax plus by plus c equals 0, and our job then now is to find a, b and c. Okay, I know that the perpendicular distance from point P, or from 3 minus 3 to the line T now, is equal to 2. Okay, so by letting x1 equals 3, y1 equals minus 3, and filling into my formula from above, I find that 2 is equal to the modulus of ax1 plus by1 all over root something squared plus something squared. A now I know is just a. x1 is 3, b remains b, y1 is minus 3, and c remains as c. A squared remains as a squared, and b squared remains b squared, and that's as far as I can go with that. Just need to tidy up what's inside the modulus and multiply across by root a squared plus b squared to clear the fraction. So that's 3a minus 3b plus c. Okay, I now need to go back to the question and see if there's any more information that I can use to get me further down the line. And I'm told that the point 1 minus 2 is on this line t. So I now know that 1 minus 2 is on t. So if I sub in 1 minus 2 to this line, I get 0. Which means that a times something plus b times something plus c equals 0. 1 for x minus 2 for y. So a minus 2b plus c equals 0. Or getting c on its own, c is equal to 2b minus a. I can then use that value for c to sub in to my last equation. So 2 times root a squared plus b squared is equal to the modulus of 3a minus 3b plus, now it's 2b minus a. Now I'll tidy up inside in the modulus bars to get 3a minus a is 2a, minus 3b plus 2b is minus b, and still is still equal to 2 times root a squared plus b squared. Now to clear the square root, I'm going to square both sides. Which gives me 2 squared is 4. All that squared gives me a squared plus b squared. Is equal to that squared becomes the first squared, which is 4a squared. The last squared, b squared, and double the product. 3 minus 4ab. If I tidy up that, I get 4a squared plus 4b squared equals 4a squared minus 4ab plus b squared. I see that 4a squareds cancel, and the 4b squared is joined by the b squared over here to become 3b squared. Bring over the 4ab plus 4ab equals 0. If I factorize that out, I get b into 3 plus 4a equals 0. So therefore b can be equal to 0, or b can be equal to minus 4a over 3. Now, if b is equal to 0, I get from my asterisk there that c is equal to minus a. And then I have ax plus, well, it'll be 0y plus c is equal to 0. But c is equal to minus a, so ax minus a is equal to 0, or x minus 1 is equal to 0, which is q, which we're not asked for because it's other than q. So, what I'm really interested in is the case where b is equal to minus 4a over 3. In that case, I sub it back in here to my general line to get ax minus 4a over 3 y plus c. Again, going back to my asterisk, c is equal to 2 times b, which now becomes minus 4a over 3 plus c, minus a. So c now is equal to minus 8a over 3 minus a, which you can put back into this equation here to get ax minus 4ay over 3 minus 8a over 3 minus a. Which is all equal to 0 from up here. So if I divide that across by a, I get x minus 4y over 3 minus 8 over 3 minus 1, which tallies up to become 3x minus 4y minus 11 equals 0, which is your final answer for the line T.